Hi guys, welcome back to another video. So in this video, we'll be solving this problem, sum of three numbers. It's a medium level problem. So let's see the problem statement. Given a list of integers, nums and an integer k, determine if there are three distinct elements in the list that add up to k. Okay, so we have to find if there exist the three distinct elements in the list that adds up to k. Okay, so let's see the sample input. We have given this nums 4113 and k is 5, so output is true, and we can pick 3 1 and 1 to get 5. Okay, so let's see how we can solve this. So we are given k equals to 3 and this array. So what we can do, the first approach is we can apply three loops and we can check every three elements in the array that adds up to k or not. Like first we will start from, suppose I will start from here and j will start from here and k will go from here to the last, and similarly j will move on and k will go from here, and at the end when j reaches to the end, then we will move our I to the second element, and it will keep going until we find that there are three elements which sum to the k. So there are three loops, so the time complexity of this approach is O of n cube, because we are applying three loops and we are checking every three elements in an array that it sums up to k or not. So time will be O of n cube, and as n is of the order 10 to the power 3, so it will exceed the time. So an efficient approach in which we can solve this is using two pointer approach. So let's see how we can do this with this. So we are given this array. So first of all, what we have to do, we have to sort this array. We have to sort this array, so the array will become like this. And what we will do, we will first take I pointer here. Suppose I is at the 0th index, and we will take two pointers. Suppose they are L and R. Suppose they are L, this is L, and at the end it will be R. And we'll check if the sum of these three elements in the inside the while loop, and there will be condition while L is less than R, and we'll check if sum of these three elements is equals to K. If sum is K, then we will eventually return true. And if it's not, if sum is less than K, then what we'll do, the sum is less than k, we'll fix our I here, and we just have to move L and R. L will go to forward and R will go to reverse direction, that is at the left, and L will go to the right. So if the sum is less than k, which means we have to increase the sum. How much? So how we can do that, we can increment our L pointer to 1. So L will be here, so that if L, because the array is sorted, so we know that the next element is greater than the current element, so we will increment so that the sum increases. So if sum is less than k, then we have to increment the sum, so we will increase the value of L, increment the value of L. If sum is less than k, then we will do like this, L plus plus. Or if sum is greater than k, then we have to decrease the, so to decrease the value, what we have to do, we will decrement this R. Like, we know that the array is sorted, so we know that the element at the left is less than the current element, where R is right now. So we'll decrease the R, so that the sum sum decreases, sum gets decreased. So this is a two pointer. First we will fix I, and we will move L and R. And if there is no case where the sum is less than, if sum is equals to k, then we'll increment our I. Like if this while condition gets broke and we didn't get any solution, so we'll increment our I. And similarly where L will be I plus 1 and R will be here. So in this case, what we can do, This is given 1 1 3. So first of all we'll take I, and L will be I plus 1 and R will be at the end. So we will check 1 plus 1 plus 4 is equals to k. So k is 5. So it's not equals to k, it's greater than k. So we will it's greater than k, so we'll decrement our R. So R will go left, so R will come here. Now we will check the sum 1 plus 1 plus 3 is equals to 5, so we'll return true, and hence we got the solution. And if our I reaches to the end and we didn't get any solution, like our for loop gets broken and we didn't get any solution, so we'll return false, because there's no three elements which sums up to k in our array after after this two pointers method. So our time complexity in this will be O of n square, because we are taking for the first loop we are incrementing our I, and here's the second loop, which is while loop, and it is also of the order O of n. So time will be O of n in this, and as is the order of 10 to the power 3, so it will be the efficient solution, it will not exceed the time. So let's code the solution out. So first we will take size. So let's first try a brute force approach with the three loops. For nt j equals to I plus 1, j is less than j plus plus, and k will be next to j, it will be k plus plus. And if, oh, sorry, k, let's take another name, let's take this L, and this is R. If nums of I plus nums of L plus nums of R is equals to k, then we will return true. And if we didn't got any three elements, so we will return false. So let's run this. What is, so R will be L plus 1. Okay, so let's run. We got accepted, but it will not pass all the test cases because of the constraints. So we got time limit exceeded. So let's comment this out, and so let's try our two-pointer approach, two-pointer solution. So we will take I, and then L will be I plus 1, and R will be n minus 1. We'll apply while L is less than R. If nums of I plus nums of L plus nums of R is equals to k, then we will return true. Else if we copy this, is if it's less than k, then we have to increment this sum, so we'll increase L, else we will decrease R. And I think that's pretty much. And if we didn't got any solution, then we will return false. So let's run this. So let's submit. We forgot to sort our elements. Okay, so let's submit again, and yeah, we got the success now, and it took 39 milliseconds, which is fair enough. So thank you for watching, and I'll see you in the next video.